Dear students, today we will see the flip-flop. Flip-flop is a basic memory element. It can store one bit at a time. Flip-flop have two outputs which have complement to each other. That means if Q is equal to 0, QR is equal to 1. If Q is equal to 1, QR is equal to 0. It have two stable states, hence it is also known as a stable multivibrator content. In this chapter, we will study the SR latch using NAND gate and NOR gate, SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. And for all this latch and flip-flop, we will see the circuit diagram, truth table, characteristic equation, excitation table and conversion from one flip-flop to another flip-flop. Let us start with a simple circuit which are developed by the NOT gate. This is the latch using the NOT gate. But disadvantage of this latch is that it does not have the control unit, that is only one input, so it cannot be controlled. So instead of using the NOT gate, we will use the NAND gate and the NOR gate. So let us start the topic with the SR latch using the NAND gate. So I am going to start SR latch using the NAND gate. Just in this circuit, we have replaced the NOT gate with the NAND gate, and in front of S we have written the Q, in front of R we have written the QR. Now already we know the truth table of the NAND gate and also written in the right side. Now we have developed the now we are going to develop the truth table for the SR latch using NAND gate. Keep in mind, we are taking the SR latch using NAND gate. So there are two input S and R. So there is 4 states: 0 0 0 1 1 0 and 1 1. First of all, we check the output for the 0 0. If S is equal to 0, R is equal to 1. In NAND gate, if any input is 0, no need to check the second input, and Q and QR both are 1. In this case, if we get the Q and QR is 1, so it is called invalid state, because definition of flip-flop say that Q and QR must be complement of each other, but here we are getting the same Q and QR 1, so this is the invalid state. Now for 0 1, SR is 0 and 1. If S is 0, then Q is, for any input is 0 in NAND gate, we get the Q is equal to 1. So if Q is equal to 1 and R is equal to 1, we will get QR as 0, which are complement of Q. So this is the output. So Q is equal to 1. Now for the case of S is equal to 1, R is equal to 0, we start with R is equal to 0. If R is 0, then QR is 1. If QR is 1 and S is 1 1 1, we will get the 0. So Q is equal to 0, which are complement of each other. Now if take input as 1 1, in this case we have to we don't know the second input, so we assume Q is equal to as 0. You may also assume Q is equal to 1. We have taken Q is equal to 0. If Q is equal to 0, then lower NAND gate will give the output 1. So QR is 1 and S is also 1. So if S is 1 and QR is 1, we will get Q as 0. That means we are getting the previous, what we have assumed, we are getting the output as that value. If we have assumed 0, we are getting 0. If we assume 1, we will get output as 1. That means in 1 1, we are getting the previous state, that is no change in state when we apply S is equal to 1 and R is equal to 1. So here S stand for set and R stand for reset. Then you can see that if R is equal to 1, then it should be reset, but here we are getting 1. And in the case of S is equal to 1 0, if S is 1, we are getting 0. That means at set means at 1, but we are getting invert of this one. Okay, so this is the disadvantage, or we can say that we are getting the opposite or inverted output. Okay, which can be if we use the NOT gate, this NOR gate, that this problem does not occur. In SR latch, if both gates are enabled, output remains same previous state, and if both are disabled, then output remains same invalid state. Okay, now next we start with the SR latch using the NOT gate. So in this case, just we replace the NAND gate with using the NOR gate, and in front of S we have written the Q bar, in front of R we have written the Q, and also we know the truth table of NOR gate, which is also mentioned in the right side. Now we are going to develop the truth table of SR latch using the NOR gate. If so again there are two inputs, so 4 states: 0 0 0 1 1 0 and 1 1. Now let us start with SR is 0 0. If SR is 0 0, that means we have to assume Q. Okay, we have to assume Q. So if we assume Q is equal to 0, then S is 0 and Q is 0. So our output will be the 1. So Q bar will be the 1. If Q bar will be in the 1 and R is 0, so in NOR gate, if any input is 1, we get output as 0. So if we assume Q is 0, we are getting the next state as 0. So for SR is 0 0, we are getting the previous state. Now for S is 0 and R is 1, S is 0 and R is 1. So we'll start with R is 1. If any input in NOR gate is 1, we are getting output as 0. So R is 1, we are getting Q as 0, and if Q is 0, and S is 0, we will get output 1, which are complement of each other, and Q is equal to 0. Now S is 1, R is 0, so S is 1, we will get Q bar as 0. If Q bar is 0 and R is 0, we will get Q as 1, which are complement of each other. Okay, now let us start with 1 1. Let us start with 1 1. So in 1 1, for in input in NOR gate is 1, we will get Q as 1 and Q bar is 1. So both are the same, Q and Q bar. So this is again invalid state, and we are getting Q and Q bar is equal to 0. So sometimes in objective question it is asked, when SR in NOR gate, if S is 1, R is 1, this is invalid state, and what is the value of Q and Q bar? So both are the Q and Q bar is 0. Remember it. Okay. Now in this case, see that if S is see the 1 0. And see the case of 1 0. And if S is 1, we are getting Q is equal to 1. That means set. If R is 1, in the case of 0 1, if R is 1, we are getting the reset, which is 0. That means this input is resetting the flip-flop. And if SR is 1 0, this is the setting the flip-flop. And if 0 0, we will get the previous state, and 1 1 invalid state. Most of the time we see that most students remember only this truth table using the NOR gate, but very different and just opposite in the case of SR latch using the NAND gate. Okay, so this we have covered the SR latch using the NAND gate and NOR gate, and now we see the advantage of where it is used. So SR latch is used to eliminate the switch bouncing. Now, bouncing means vibration of switch when on or off, and when we go from on to off, that time bouncing, so to provide some delay, so that type of bouncing is removed. Now let us start with the SR flip-flop. So far we have seen the SR latch. Now we will start the SR flip-flop. So in SR flip-flop, just we use right part. Just see the right part. We are using the same SR latch using the NAND gate, but we adding the extra circuit, which are 2 NAND gate, and given the one of the input of 2 NAND gate we have taken is common as clock. Okay, we are providing a clock to the same to the both of the NAND gate, and one is S input and second is the R input. Again there are so first of all we have the circuit diagram of SR flip-flop. Okay, remember this circuit, and just we have taken the NAND gate and 2 extra NAND gate we have added in this case. Okay, now we also be taking the clock here. Now we will see the truth table of SR flip-flop. Okay, using the and we are using the NAND gate, SR flip-flop using the NAND gate. We will see the truth table. Now here we are using the 2 input S and R, and also we are using the clock. So if what will happen if clock is equal to 0? If our bike has a have a petrol and everything, but we don't have the clock or key, then it can be start. No, cannot be started. Similarly here, if we apply the clock is equal to 0, and here we have given the S is equal to star or R is equal to star, that means don't care. We have taken the don't care. Then if anything either S is 0 0 or 0 1 1 0 or 1 1, we all combine in one group, which is represented by don't care. So if clock is 0 irrespective of S and R value. So in NAND gate, if any input is 0, we will get output as 1. So we will get output as 1 after the first NAND gate. In both first NAND gate 1, and in SR latch using NAND gate, we will see that we have already seen that if input is 1 1, we get the previous state. Okay, that means if we don't apply the clock, output never changes in flip-flop. Flip-flop output may change only if we apply the clock. Until or unless we don't apply the clock, remember it, output will never change in flip-flop. Okay, so if clock is equal to 0, we will always get the previous state, or this is also called hold state because it is holding the value, previous value. Now if clock is equal to 1, and then we are getting the 4 combination 0 0 0 1 1 0 and 1 1. We will see one by one. First of all, start with the 0 0. So if S is equal to 0, R is equal to 0, any input is 0, so we will get the 1 1, which are the already we have. After that, first NAND gate already discussed. When it is 1 1, we will get the previous state, that is Qn. Okay, here Qn plus 1, don't confuse Qn plus 1. Qn plus 1 is just the next state. If Q1 is happening now, then Qn plus 1 is happening in the next step. So Qn plus 1 is next step, and Q1 is represented by, in the previous state, represented by Qn here. If Qn plus 1 is next state. Now when SR is 0 1, if S is 0 and R is 1, so if S is 0, we will get in front of S of the NAND gate, we will get the 1, and in this gate we will 0, that means 1 0. So in the case of 1 0 in SR latch using NAND gate, we have seen, or we will get the output as 0. Now in the case of 1 0, we will get output as 0 and 1 after first NAND gate, and this is the case when in SR latch when input is 0 and 1, we get output as 1. But in the case of SR is equal to 1 1, we will get 0 0, and which is the invalid state or unused state. So we have seen the SR latch using the SR flip-flop using the NAND gate, and its truth table is when it is SR is 0 0, this will get the previous state, and 0 1, it is resetting the value, so it is called the reset state, and 1 0, because S is 1, it is set state, and we are getting output as 1, and if it is 1 1, we are getting the invalid state. We are getting the same output as SR latch using the NOR gate, remember it. Okay, na? Now next we will see the just we have taken the truth table in compromise manner. 0 0, we are getting the Qn. For 0 1, we are getting the 0, that means resetting the value. If 1 0, we are getting the 1, and 1 1, we are getting the invalid state. Now we will see the SR latch using the NOR gate. Think that in SR latch using the NOR gate, we are getting, for set S is equal to 1 and 0, we are getting the set, and for 0 1, SR 0 1, that means R is equal to 1, we are resetting the value. So what we want, we are getting the same, so here no need to invert. So simply just in the NOR gate, we have using the AND gate instead of NAND gate in the SR flip-flop using the NAND gate. Okay, so in SR flip-flop using the NOR gate, we use the AND gate, remember it. And input of one input of AND gate we have taken as common, and we are supplying the clock from this input. Okay, so and truth table is, you can just, as similar to previous section, you can say truth table is same as for the NAND gate SR flip-flop. So in this we can say that for SR latch using NAND gate and NOR gate, truth table is different. But for SR latch using flip-flop, truth table is same. Okay, and remember it. Okay, if SR 0 0, we will get the previous state. If SR 0 1, it is reset state, that is 0. If 1 0, that is set state, that is we will get output 1. If 1 1, this is invalid state. So we have finished the circuit diagram, we have finished the truth table. Okay, now we see the in next section